Hey guys, welcome back to our channel. So with this video, we are going to start a new series which is going to be dedicated to end-to-end data science projects, where what I will do is I will take various data sets and the questions that have been asked in various take-home assignments of various companies, or they are open-ended, like for example, data sets from Kaggle, etc. And then try to go step by step and explain you how to approach these kind of questions. So we are going to cover all the exploratory data analysis, questions based on business analysis, regression, data engineering, classification, natural language processing, etc. from a lot of various companies. So if you have been waiting for such a series and want to learn machine learning, data science, Python, etc., this playlist is for you. So from this video, we are going to start the first one. So this company Uber has this take-home assignment, right? This project has been used as a take-home assignment in the recruitment process for data science positions as Uber. So what we are going to do is we are going to have these data sets, and then there are a lot of, I think there are about 11 questions that we need to answer based on that. So we are going to do step by step and try to learn from it. Okay, and you do not need to worry if you don't have access to Strata Scratch or premium version of Strata Scratch, that where will you find these datasets, etc. I have recently started the GitHub profile for Everyday Data Science. In this, I have made a repository called Data Science Projects, where I'm going to upload all the data sources, the final Python notebooks, etc., along with what has been asked in the questions, etc., so that it's easier for you guys to, directly load data sets from this. So for example, if I look at the one that we are going to do in this video, so if you go to the insights from city supply and demands repository and go to the data section, so this is the data set that you have, and you can directly load this, and we will learn about how to do all this and perform your exploration. Okay, so what I'm going to do is I'm going to use Colab, right? What you basically need to do is you need to go to this website called colab.research.google.com, where you don't have to use Anaconda or a ID on your personal laptop. You can just directly use resources from Google. And this is completely free. You don't have to do anything. I think all they ask you for is just to sign up. Okay, so I went ahead and copy pasted all the 11 questions that have been asked, and we are going to develop and try to answer one by one. Okay, so the first thing that we need to do is we need to load the data set, but for reading the data set, we need certain libraries. So let us try to start with the libraries part. So libraries, okay, let us import pandas at pd, and then let's also import numpy. So let me just import numpy as np as well. Okay, let me run this, and then what we are going to do is we are going to copy the URL of this data set. So this data set, if I go ahead and just write raw here, click to this website, and this is going to give you a link. Just copy this and go back to the Colab part, and let's write URL is equal to, this is the URL that we have. And then what we are going to do is data frame is equal to pandas dot read csv, and then you read from this particular URL. And then what we are going to do is df dot head, so that let's see if we have read the data set correctly or not. Okay, so now if you look at this, we have the date column, the time column, eyeballs, zeros, completed trips, request, and unique drivers. So we have all these columns. Now, what we need to do is we need to understand what all these various columns mean. So if I go back to the original question, here they have given you an example. So here, for example, this data description, it says that if there is a row like this, what it basically means is that, so this is the date that you have, and this is the time or local. Basically, this is the hour, right? So this 16 means 4 p.m. That is between 4 p.m. to 5 p.m. There are 11 people who opened the Uber app, right? So eyeballs is how many people are opening the app. Zeros is basically two of them did not see any car, and four of them requested a car. So this is request. Out of the four requests, only three complete trips actually resulted. And during this time, there was a total of 6 drivers who logged in, that is unique driver. So once we have this information, then what we need to do is, so once we have this data and information that what all various these things means, just by looking at it, you can see there are a lot of null values in the date column. So what should we do is, let's start inspecting this data frame. So how to perform an inspection? There are certain ways. What you can do is, you can find missing values, you can find duplicates, what is the shape of this data frame, basically how many rows and columns they have, what are the name of various columns, etc. Right? So let us try to add a new code column, and then let's do initial inspections, right? So let me just comment it out, initial inspections. Okay, the first thing that we should do is, let us print the shape of the data frame. So if I do df dot shape, it is going to give me how many rows and columns there are. So there are 336 rows and 7 columns. Okay. And then what we are going to do is, let us see how many null values are there in each of the columns. So if I do df dot is null and then perform a sum, it is going to give me that in each of the columns how many null values are there. So if you look at it, only date column has null values, and out of 336 rows, 321 are null. What does this tell you? That there is something wrong with this, right? And before proceeding to all the questions, what we need to do is, we need to find a way to impute this missing values. So let's try to see what is actually happening. So if I go ahead and write this, and let me just do this df dot head, and let's say 25. Okay, so if I go ahead and run this, let's see what do we get. So here, if you look at this, so you have this 10th of September 7 a.m., right? So 7 a.m. And then you have all the nulls until 23, right? So our 11 p.m. to 12 a.m. and then 11th of September, and then so on. So basically what in this data set you have is that you have a starting date, and then basically since all of these dates are the same, so that is why you have null. So you found a way to impute the null values in this. How? You need to perform a forward fill of the date column, right? So we see that this is a time series data, and we can perform a forward fill. How can we do that is, we can do that, hey, so once we looked at this, we don't need to all, have this here. So what we can do is, let us take the date column, right? So df dot date is basically what we need to do is, we need to use dot f fill, so forward fill, and then you need to fill it row by row, right? So axis is equal to 0, and then in place is equal to true. And now let us look at df dot head of 25, and let's see if it has been properly forward filled or not. So now if we look at it, we have the data in the correct order that we want. Okay. Now once we have this, then let's try to again check if there are any null values that are remaining. How can we do that is, let us just add a new one. So df dot is null, and then dot sum, and let's run this. So now if you look at it, none of the columns have any missing values. So now we have dealt with the missing values part. Then let's look at if there is any duplicated rows. So now if I go ahead and use, let's look at duplicated part. So what we are going to do is df dot duplicated, and then dot sum, and let's look at run this. So it says 0. So there are no duplicate rows. Now once we have done data pre-processing, there is no missing values as well. Okay, we already checked the shape, right? There are 336 rows and 7 columns. Let's look at the data types of each of these columns to see whether they make sense or not. So what we are going to do is, let's use dot info. So df dot info. Let me run this. So now if you look at this, there were total 336 rows. None of them are nulls as well, as we see. And then date is an object type, and everything else is a integer data type, which does make sense. Okay. Now, once we have the data in the required format, let us go ahead and start with the first question. Okay, so the first question says that which date had the most completed trips during the 2 week period. So kind of very simple. All you need to do is, if you look at this data frame, right? So what we should do is, let's try to look at df.head. So basically what we right now have is various dates, times, and it asks us on which particular date there are maximum number of completed trips. So we can group by the date column, take the completed trips column, perform a sum, and then sort in descending order to get the date on which there are most number of completed trips. So if I go ahead and add a code column, let's do that. So df dot group by the date column, and then use dot aggregate function. What is the name of the column that we want? We want as completed trips or total completed. So total completed is equal to which column do we want? We want the completed trips. Okay. One thing that we should do after this is we need to, let's use what is the name of the column. So because the problem is, even though it looks neatly formatted, but there are times when you have a white space here or there. So what we should do is, let us run this, and if you see there are white spaces after certain columns but not after others, right? So after completed trips there is actually a white space. So let us copy this. It would be useful throughout this project. Okay, so what we're doing is, take the column called completed trips, perform a sum, right? And let us do dot reset index. Let us see what do we get in our output. Now, if you look at it, you have basically various dates and total completed. What we want is, we need to order by total completed in descending order. So let us do dot sort values by which column? By total completed descending order. So ascending is equal to false. Let me just bring it down. So ascending is equal to false. Let me go ahead and run this again. Let's see what do we get in our output. So now if you look at it, 22nd of September 2012, there are 248 trips that have been completed, right? So since we need only the first one, what we can do is, we can go ahead and simply write dot head, return me only one row, run this. So 22nd September 2012 is the date where we had the maximum completed trips during the 2 week period. Okay, so to solve this question, let us try to do this. Let us again look at the data frame that we currently have. So this is what we have currently, and then what we need to do is, within a 24-hour period, right? So just think about it. What actually it means is, 24-hour period can be any, right? So for example, 10 September 2012 from 7 a.m. till 11 September 2012, 7 a.m. Right, so that is 124-hour period. Then if you look at from this, so 8 a.m. to 8 a.m., 9 a.m. to 9 a.m. So basically for each of the dates, you need to calculate 24-hour period, and then try to calculate the highest number of completed trips between that 24-hour period. So you might be thinking we need to do a lot of for loops and all that, like, but what you basically need to do is, we can use a function called rolling sum and specify the time frame that we are going to use. But for that, what we need to do is, let us combine this date column along with the time, so that we have a date time, that is 10 September 2012 7 a.m. That is one particular column, so that it's easier for us to calculate that rolling sum. So what we are going to do is, let us create a column called date time, which is basically how we are going to calculate it is, so pd dot to date time, and then what we basically do is, let us take the date column, and then what we are doing is, let's have a space, so that the date is separated by time with a space. And then what we are going to do is, plus take the column called df time local, right? So df of time local, and we saw that every column apart from the date column is a integer type. Here you have a date time, right? Basically this thing is, right? So this is a string. This is also a string. So obviously you need to convert this column to a string, right? So what you can do is dot as type string, and then what you need is let us add zero zeros. So what you're basically going to do is zero zero, so hours and then minutes. Okay. Now once we have this, let us try to see what do we have. Let me run this. So now you have a date time column, and you see you have a lot of these, and obviously they look bad and not pretty when you are trying to work with Python notebooks. So one way to avoid these kind of warnings is to ignore such kind of warnings. So let us go back up in the libraries part and let's try to do this. Let us import warnings, right? So let's import the warnings library, and then basically what you do is ignore these warnings. Let's run this, and then let us go back to wherever we were. So here, this is what we have, and let me go ahead and run this again. So now you are not being shown that particular warning. Okay, so this looks particularly clean. Then what we have is we have the date time column, and then let's perform the rolling sum. But to perform that rolling sum, there is one additional step that needs to be done, is that right now the index of this data frame is 0, 1, 2, 3. What we can do is we can set this column date time as index, because then only the rolling function will work. So what we are going to do is df dot set index time column, and in place is equal to true. Now if I look ahead and let's look at the df dot head, so this is has been a index. Okay, once we have this, then let's try to create a data frame called rolling sum. And then what is basically we are going to do is we need to calculate which 24-hour period has the maximum completed trips. So df take the completed trips column, and in the 24 hours, right? So rolling 24 hours, perform a sum and let us return the head of the particular data frame that we are going to create. So what does this actually do? If you look at it, right? So 7 a.m. 2, 8 a.m. 4, 4, 4, 8. So basically, if you look at this, what is this line of code doing? So 7 a.m. completed trips are 2. So one row is assigned. Then if you go to 8 a.m., so basically what is the total number of completed trips? 2 plus 2, 4. Then 9 a.m. plus 0, that is 4. 10 a.m. plus 0, that is 4. And then plus 4, that is 8, right? So you see, for every date time, you have the completed trips. Okay, now once we have this, basically, if I go ahead and sort this by completed trips in descending order, we are going to have, okay, when was the maximum number of completed trips? So let me do this, df rolling sum, and then what we are going to do is sort values by ascending is equal to false, and let us return what do we have here. So now if you look at it, so this is the time, right? So 22nd of September 16, that is 4 p.m. That means 4 to 5 p.m. you have the highest number of 278 trips, right? But look at this. So here, for example, when you have this, right? So let's just take these 5 rows. So which one has the maximum? This row, right? So 11. So basically what it means is between 7 a.m. to 11 a.m. on 10th of September, there were 8 completed trips. So when it says 22nd of September 2012 at 4 p.m., this was the 24-hour period with the highest completed trips. What does it actually mean? So we learned that when it says 4 p.m., it means 4 to 5 p.m., right? So you have an hour. So basically, this ends, so 278 completed trips till 5 p.m. of 22nd September 2012. That means 24 hours before that is going to be 21st of September 2012, 5 p.m. So 21st of September 2012, 5 p.m. to 22nd of September 2012 5 p.m. is the 24-hour period which has the maximum completed trips, right? So you see here, this is the question: highest number of completed trips within a 24-hour period, and that is 278 trips. Even though this question has only asked like what was the highest number, we can just go right and 278. But if they also ask you what is that actual time frame, so here what you can do is either you can just explain all this, or a simpler way to actually know when did this 24-hour period start is subtract 23 hours from this. Why 23 hours? Because again, this is 16, that means 4 to 5 p.m. So if you subtract 24 hours from 16, that you are going to reach 21st of September 2012 4 p.m. You don't need that, right? You just saw that this is 4 to 5 p.m. So if you subtract 23 hours, you are going to reach 5 p.m. of yesterday. So how can we do that? Is instead of, once you perform the sum, shift it by 23 hours. So what we do is shift minus 23. And now if I go ahead and run all, so if you look at it, 21st of September 2012, 7 p.m. So 24 hours after this is when you have the maximum number of trips. So what we can do is let us just write head 1 and rerun this, and this is what we have. So basically between 21st of September 2012 5 p.m. to 22nd of September 5 p.m. 278 trips is the maximum number of trips in a 24-hour period. Okay, the reason why I did this question using this, because there are a number of other questions in this particular project where you are going to use the same concept on various columns. Okay, now let us go ahead with the third question, is that which hour of the day has the most request during the 2 week period? Again, this is quite simple. This is very similar to the first one, that which one had the maximum number of completed trips. So just to save our time, let me just, copy this entire thing, because it is kind of same. What we basically need to do in this question is instead of the date, it is asking for the time, right? So the time column is basically time local, right? So time local, you are grouping by the time local, and then we need the request, right? So total request, and what you need to do is take the requests column, right? So if you look at this data frame, we have the request column. So requests, perform a sum, reset the index, sort the values by total request, and then in descending order, because it says the hour with the most request during the 2 week period. And let me remove the head for a moment, and let's see what do we get in our output. Now if you look at this is the hour, that is 23rd hour. That means 11 p.m. to 12 a.m. is the hour where we have the maximum number of requests, which is 184. So let me just go ahead and just use dot head here, so that it's easier for us to 23rd hour 184 total request. Okay, now fourth question says what percentage of all zeros during the 2 week period occurred on weekend, that is Friday at 5 p.m. to Sunday at 3 a.m. Okay, so let us again look at the data frame that we currently have, df.head. Okay, date time being the index. Let us reset the index. So what we are going to do is data frame is equal to df.reset index, so that date time is no longer an index. So now if you look at it, this is basically the date time is as a column, not an index. Then what we need to do is we need to find basically what day this particular date fall on. So what we can do is let us create a new column. So let's call this as day of week. And then what we are going to do is let us take the df dot date time column, and then use the date time library, so dt, and then day name. But since this date time library we need to use, so firstly we need to import it. So here what we can do is import date time library as dt, and let us run this. Okay, now let us go back to our question number 4, that is day of the week. Let me go ahead and run this. Let's see. Okay, so now we have the day of the week. Now the question asks us what percentage of all zeros during the 2 week period occurred on a weekend, that is Friday at 5 p.m. to Sunday at 3 a.m. Basically, let's find the numerator first, right? So numerator is basically going to be zeros that occurred during this weekend and then divided by the total sum of zeros column. So let us see, okay, numerator is basically is equal to, we need to perform Boolean indexing that, hey, f of day of the week should be, right, day of the week is equal to Friday. Df of time local is greater than equal to 15, right, greater than equal to 15. So this is one condition, that if it is a Friday, so on or after 3 p.m., then entire Saturday and then till Sunday 3 a.m. So this is condition 1, or that is entire Saturday. That means what you do is df of day of the week is equal to Saturday. So there is no condition for the time in this case. Or df of day of week is equal to Sunday, and it says before 3 a.m. is less than 3, right? So that means 2 to 3 a.m. So these are the three conditions that needs to be satisfied. And if you pass this entire thing to data frame df, that is going to have the weekend part. And if you do dot shape, it is going to give you those rows. So instead of, having this, let me just remove the numerator part here, and let's see what do we have in this case, right? So it's easier for us to visualize. So you look at this, right? So it is Friday, Saturday, Sunday, Friday, Saturday, Sunday, right? So this is the entire weekend. So basically now what we need is, we need that you take the zeros column and perform a sum, right? Because it's asked you what is the percentage of all zeros. So let us do, take the zeros column, right, take the zeros column and perform a sum. And does it have a white space after this? Let us go ahead and look at the columns part. So zeros does have a white space. So zeros, if we go ahead and do this, zeros and perform a sum, let us see what do we get in our output. 641 is basically the total sum of zeros on weekend, right? So basically, if I go ahead and write numerator is equal to this, and then we also need the denominator part, right? So denominator, it's easier for us. What we basically need to do is take the zeros column and basically perform a sum, right? So zeros dot sum. And if we look at our denominator, it is going to be 1429. So it asks us what is the percentage of all zeros. So you basically divide numerator and denominator. So if I go ahead and add this, so numerator divided by denominator, multiply this by 100 because it's a percentage, and let's round this to 2 decimal places so that we get the accurate percentage. If I go ahead and run this, it is going to be 44.86 percentage of all the zeros occurred on weekend. Okay, now we have been done with this question number 4 as well. Now it asks us, the fifth question is, what is the weighted average ratio of completed trips per driver during the 2 week period? Weighted average means your answer should account for the total trip volume in each hour to determine the most accurate number in whole period. Okay, so it basically means ratio of completed trips per driver, and then it asks us the average ratio, and that should be weighted, not normal. Again, let us do step by step. Let me add 2 3 cells. Okay, so let's firstly inquire, okay, this is what we have currently, df head. Okay, it asks us the ratio of completed trips to unique drivers. That means it is a division by unique drivers, and if this comes out to be 0, if like unique drivers is 0, then it is going to have a ratio that is infinity or not defined, etc., right? So the first thing that we should do is we need to only keep those rows where unique drivers is greater than 0. Then only you can calculate the correct ratio, right? So what we are going to do is, let us keep the unique drivers greater than 0, and then this entire thing, if passed with the data frame df, it is basically going to perform boolean indexing, right? And if I go ahead and do dot shape and try to find out, so initially we had 336 rows, you remember? And here what we have is 297. So there are 39 rows where we have 0 unique drivers. Okay, so we just inquired about this, but what we want is, let us save this data frame into, let's call this as df or drivers. Okay, so this is the data frame that we currently have, df drivers, and then we need to calculate the ratio, right? So let us calculate the ratio, and which is basically ratio of completed trips to unique drivers, right? So this is what we have, unique drivers. And let us look at and this data frame should be df drivers, right? Because we created this df driver. So let us just paste it here, df drivers, and this should also be df drivers. And let us see what do we have in this df drivers data frame. So this is the ratio of completed trips to unique drivers. Now the question says, what is the average ratio? We will go to the weighted part, but let's look at what is the normal average ratio that you are going to get. So how to calculate normal average, right? So if I go ahead and the normal average ratio, that is going to be np dot average, take the df drivers ratio column, and let me go ahead and run this. So the normal average ratio is going to be 0.4743, but it asks us, no, do a weighted average. And what does weighted average means is, total trip volume should be taken into account. Okay, so these completed trips actually become the weight. So how to calculate the weighted average ratio is, to calculate the normal average ratio, we just took this column and performed an average or a mean out of it. But to calculate weighted average ratio, what you need to do is 2 multiplied by ratio plus 2 multiplied by this. Basically, these becomes the weights, right? And you do all that, sum that, divided by the sum of completed trips. Again, you can go ahead and do numerator and denominator in this case. Numerator is basically going to be df drivers, take the ratio column, right? And then multiply it by df drivers into completed trips, right? So that is going to give you the numerator parts, right? So if I just go ahead and do sum of this entire thing, and let's look at what is the numerator that it looks like. So this is what we have, the sum. And what will be the denominator like? Denominator will be this entire sum, right? So basically denominator is equal to sum of df drivers completed trips, right? So completed trips, this is what we have. So if I go ahead and look at what is the denominator, what is the denominator that we are going to have is 1364. So basically, what is the weighted average ratio? That means weighted average ratio is going to be numerator divided by denominator. Let me go ahead and run this. So 8.8282. So you see there is a difference between normal average ratio and weighted average ratio, right? So this is what the weighted average ratio of completed trips to driver looks like. Okay, we are done with question 5 as well. Now let's look at what is question 6. So it says, in drafting a driver schedule in terms of 8-hour shifts, when are the busiest 8 consecutive hours over the 2-week period in terms of unique request? A new shift starts in every 8 hours. Assume that a driver will work same shift each day. So basically, this question is very similar to the question number 2, right? So the 24-hour period, how highest number of completed trips, right? That is what our question number 2 was. So similarly, we need for 8-hour period, what is the busiest 8-hour, 8 consecutive hours in terms of unique requests, right? So this one. So what do we need to do in this case is, again use the same code, right? So that is why I have built this project using this trick, because it is very easy to just extend it to other questions. So let me just copy this, because it's like kind of writing the same thing again and again. What we are going to basically do in this question is that you again set the index to date time in place is equal to true. Why? Because if you look at this data frame we had, right, if you look at df, right, so this is not a index right now, it is a column. So we set that as a index. Then what we do is it question us in terms of unique requests, right? So instead of completed trips, what you need is request, and it should be 8 hour sum, and instead of shifting by 23 hours, it should be shifted by 7 hours. Why? Because if you are doing 8 hours, we saw that if you shift it by 7 hours, it is going to basically give you, okay, at the start of what hour, 8 hours from that, we are going to have the maximum number of unique requests. So if I go ahead and run this, let's see what do we get in our output. Okay, and we need to basically what we need to do is we need to sort this, right? So if I just add another good cell, so what we are basically going to do is take the df rolling sum and sort values, right? So sort values ascending is equal to false. Instead of head 1, let's do head 5. Let us run this. So what we need is, so you see there are two 8 hour periods where we have the maximum number of requests. One is September 21, 2012, 5 p.m. till September 22, 1 a.m. if you add 8 hours to this. And another is September 22nd, 2012, 7 p.m. to September 23, 2012, 3 a.m. Right. So these are the two periods where you have the maximum number of requests. So we saw that. Let me just do head 2, and this is what we have. Okay. Now, question number 7 is driver supply always increases when demand increases during the 2 week period. Is it true or false? Okay. The first thing that we should do is we know what is driver supply in this data frame. If we look at this df, what is driver supply? It is unique drivers. But what is demand? We learned that eyeballs basically refer to who all opened the Uber app in that particular hour and are looking for rides, who all did not see a particular car, and how many requested, out of which how many there were completed trips. So basically, what is the demand in this? Demand is the eyeballs column. Why? Because there are a people, these many people who are actually looking for a car. So the question says now that driver supply always increases when demand increases. So basically what we need to do is let us plot a graph between the eyeballs and the unique drivers and see whether it always increases during the 2 week period or not. But first, let us reset the index. So df dot reset index and df dot head. Let me go ahead and run this. So now this is what we have. Okay, now to plot this, we need to use matplotlib. We have not yet imported matplotlib. So let's go here and do import matplotlib.pyplot as plt. We don't need cbond, but okay, let's import it. That does not matter. Okay, now let us go back to this, and what we are going to do is let's plot this. So plt dot plot. Let us first plot date time on x-axis. So df date time on x-axis, and then let's plot df eyeballs on y-axis. Let us give a certain color to it, right? So color is equal to red, and label this as basically what is this? Eyeballs are demand, right? So a label is equal to demand. Similarly, let us do that for unique drivers. So let me just, okay, legend plt dot show. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so this is what the demand looks like, and it's not easier for us to visualize. So let's try to, format this in a bit. So what we are going to do is firstly, let's increase this size. So plot dot figure, and then basically fig size, let's say 15, 5, or Okay, so if you look at this, so just by looking at it, the question says driver supply always increases when demand increases. Okay, whether it is true or false. So demand is red one and supply is blue. So it says as demand increases. So here if you look at it, right? So basically that start at 7 a.m. So it's increasing and then again increasing, but if you look at the supply it decreases. So just by the first part of the graph you can say that it generally increases, because if you look at it, right, if you just look at the general trend that as demand increases supply is increasing, but is it always the case? No. So the answer should be false, right? So what we can do is the answer is basically going to be false. That is, generally it does, but not always. Okay. Now it asks in which 72-hour period is the ratio of zeros to eyeballs the highest? Again, very similar to question number two that we solved, right? So what we need to do in this case is date time is reset. So this is not an index right now, but to calculate the rolling ones, we need that. So let us try to do this that, hey, df dot set index date time and in place is equal to true. Then what we are going to do is what do we need? So 72-hour period, the ratio of zeros to eyeballs. So every 72-hour period, calculate the sum of the zeros, then calculate the sum of the eyeballs, and then perform the ratio part. So, and again, since we do the sum, we need to shift it by 71 hours so that it's, tells you the starting time. So let's do that. So shift it by minus 71. Similarly, do this thing, right? So shift by minus 71, and what we are going to do is let us run this. Let's see what do we get in our output. So basically this is the ratio. What we are going to do is let us do sort values, right? Sort values, ascending is equal to false and head is, let's do 5. Let me go ahead and run this again. So basically if you look at it, 15 September 2012 5 a.m. till 18 September 2012 5 a.m. is the highest ratio of zeros to eyeballs. Right. So let us just do head 1. Okay. So this is the 72-hour period starting at this time, which has the highest ratio of zeros to eyeballs. Okay. Now question number 9 says if you could add 5 drivers to any single hour of every day during the 2-week period, which hour should you add them to? Consider both rider eyeballs and driver supply when choosing. So basically, when the mismatch of supply and demand is highest, adding the number of drivers, so 5 drivers, would be the best. Why? Because if the mismatch is high, if you add more drivers, they can meet the demand. So what we can do is, first thing is, let us reset the index to df is equal to df dot reset index, and let us look at this data frame. Okay, now what we are going to do is for every time we are going to calculate the total sum of eyeballs and the total number of unique drivers and then calculate the ratio of that, right? So what we are going to do is df dot group by the time column, right? So time of local. Then what you do is dot aggregate. Firstly, we need the total eyeballs. So eyeballs dot sum, total drivers is unique drivers dot sum and reset index. Let me go ahead and run this. Let's see what do we get in our output. So basically what you have is total eyeballs and total drivers. Then what we can do is let's save this in a data frame called I versus drive, right? And what we are basically now going to do is add a ratio column, right? So I versus drivers, and let's add a ratio column to this. Basically is going to be I versus total eyeballs versus total drivers, or you can do the other way around as well. So I versus driver, total drivers versus, right, total drivers versus total eyeballs. And now look at this. Okay. So this is the ratio that you have. So obviously here what we did was total drivers divided by the, so basically supply divided by the demand. The lowest ratio means demand is high and supply is low. So whichever hour has the lowest ratio, that is the best hour. What we can do is, let's sort this by, so sort values by ratio in ascending is equal to true, right? So ascending is equal to true, and let us return head 5. Let's run this. So basically our 23 has the minimum ratio of supply to demand. That means if you add 5 drivers here, it is going to meet the demand in a better way, right? So if I go ahead and do head 1, so our 23 is basically the one where you should add 5 drivers. Okay, now question number 10 is, so let me just delete this. Question number 10 is, there is exactly 2 weeks of data in this analysis. Okay, let's look at this. So if we just do df dot head in this case, what we have is, okay, this is the data frame that we have. So if you go ahead and let me just add code, let us look at df date time minimum, right? So df date time dot minimum. So when does this start? It starts at 10th of September 2012, 7 a.m. So if it is exactly 12 weeks of data, the maximum of this should be, if you add 14 days to this, 24th September, 6 a.m. Let us, okay, so df date time maximum, and you see, right? So 24th September, 6 a.m. When it says 6 a.m., it means 6 to 7, right? But not including 7. So you see, it started at 7, 10th of September, and ended at 6 to 7 hours. So you remember 6 means hour 6 to 7. So that means yes, answer is true, right? So if I just have this answer, the answer is going to be true, that it has exactly 2 weeks of data. Answer is true. Okay. Now, the final question of this is, looking at the data from all 2 weeks, which time might make the most sense to consider a true end day instead of midnight? That is, when are supply and demand at both their natural minimums? Visualize the data to confirm your answer if needed. Okay, so the first thing that we should do in this case is, we should firstly group by the time and see, okay, what is the sum of the unique drivers, that is the supply, what is the sum of the eyeballs, that is the demand, and plot that to say that, okay, overall in these 2 weeks, at which hour the supply and demand were the lowest. And once we get a time range or a hour range, then let's plot this entire 2 week data frame to see whether it confirms or not. So let us first do this. Let us create a data frame called minimum is equal to df dot group by the time local, right? Time local. And then what we are going to do is total eyeballs and total drivers, reset index, and let us look at this data frame, right? So minimum. Okay, so this is what we have. Now let us plot this as well. So what we are going to do is plt dot plot. Okay, so basically this is demand and supply, and then plt dot show. Let me go ahead and run this. Let's see what do we get. So if you look at this, this is the demand part, this is the supply part, right? So if you look at this, let me just add markers as well, right? So that it's easier for us to count, okay, which hour this is. So marker is equal to O in this case, and X in this case is equal to X. Let me rerun this. Okay, so now if you look at this, this is our 0, 1, 2, 3, 4, right? So looking at the entire 2 week data, our 4 and 5, right? So usually these are the ones where you see the minimum supply and minimum demand. Okay, let us try to verify that, okay, the question's answer can't be that instead of midnight, the true end day could be 4 a.m. or 5 a.m., right? Or between that time period. But let us try to plot this entire thing from the first time the data appears to the last data. So what we are going to do is plt dot plot df date time, right? And then what we are going to do is, this is x-axis, then eyeballs, demand, and so on. So let's do this. Let me go ahead and run this. Let's see what do we get. Again, let me just increase the size of this as well. So plt dot figure fig size. Let me run this. Okay, now what is missing in this case is the we have the dates, but let's add the hours part as well. To do that, we need to use this line of code. So basically x-axis, so we are basically formatting date using the mdates function. In not only have year, month, and date, but also have the hour and month, because date time has hour and month as well, right? But we need to import this mdates. So what we are going to do is import matplotlib dates as mdates. Okay, let's run this. Let us go to the question. So here, if I go ahead and once we have formatted it, now this is going to increase, right? So let us rotate this as well. So let us rotate the x ticks. So plt dot x ticks rotation equal to 90. Let's run this. Let's see what do we get. Okay, so now if you look at this, we have the date and times, but still it's very sparse. So what we are doing is, let us change the interval this x appear, right? So to do that, what we are going to basically do is every 8 hours plot this, right? So plot this tick. So use this major locator at interval 8. So at every 8-hour interval, add this. Let me run this again. Now if you look at this, this is every 8-hour interval we have this. So we saw from this that hour 4 and 5 is the one when we have the minimum supply and demand. And if you look at this, so usually around the hour, right? So 4 and 5, right? 4 and 5. This is the time. If you look at the entire data frame, this is exactly the time when we have the minimum supply and demand. So thus the answer of this question becomes that instead of midnight, the true end day could be 4 to 5 a.m. of every day. So yeah, this is how we solve this entire thing. Again, as I mentioned, this entire IPython notebook will be in the GitHub. I The link will be in the description box below. So yeah, this is how we do it. Let me know if you are able to solve this in a different way or in a better way. And we will continue this series on various other datasets as well. I will see you guys in the next video.